Welcome to my channel. In this video we are going to create a demo application. In this application we are going to connect to a Postgres database using Spring Boot application and through GPA. So we are going to learn how to run Postgres locally using Docker and how we can build a Spring Boot application to connect with that Postgres. So let's get started. First of all, let's start by creating our application. We can name it whatever we want. Start with demo Postgres. Okay, it's gonna be, we are going to use Maven for our dependency management. Let's keep everything as is. Okay, hit next here. Of course, we are using IntelliJ, as you can see. We will start getting our dependency that we need for the application. First of all, of course, we need the Spring Web. Also, we're gonna need the GPA for connecting to database. Also, let's get Lombok, and let's see, actuators gonna be a good thing to have in any Spring Boot application. I think Postgres SQL driver, we need that. So, because we are going to connect to Postgres, so we need that driver. And let's hit create. And here we go. This is our application. Okay. So before we start building our controllers, resources, whatever, let's get down and get that Postgres Docker image in our local PC. So in order to get that, see, I am doing that without any preparation, so you can get the full picture. We can do mistakes together. So let's say Postgres Docker image. Okay, this is the official Postgres. Where is the snapshot? Oh, sorry, it's here. So after getting this one, the snapshot of the Docker image, so just copy it and then go to your terminal. Of course, I'm using Mac here, but it's the same thing for Windows, not that difference. So just pull that here, so we can pull the Docker image. Okay, it's a Docker daemon is not running, so you must have Docker. I'm using Docker desktop. All we need to do is just turn it on. Okay, we ran into some problem in our Docker, so I have to pause the video, restart the Docker, and now let's run that command again. Okay, now it's unable to find the image because I already deleted that. So now this command will pull the image of Postgres and run it after that. Okay, here we go. Now if we went to our Docker, we will find that there is a container for Postgres is being running. So now before going back to our Spring Boot application and start doing the integration with this database, we need to explore that database. I'm using dpweaver. It's actually a good IDE to get into your database, build your tables, explore tables, etc. etc. Okay, I have some databases that is already integrated here, so don't worry about them. We will start a new one. Okay, it's a Postgres connection gonna be. So it's localhost. This is now the name of the database was demo database. Okay, the user is demo1 and the password we used is 1971. Now let's test the connection, and here we got connected. The connection was established successfully, so let's click on finish and it will load the database. And here we go. This is our Postgres database is ready to be used. Now as you can see, it doesn't have any tables. So now let's get back into our Spring Boot application. Where was it? Here, it's here. Yes. We need to connect our Spring Boot application to that database. In order to do that, we need to define the database properties in the application property file. So let's start by we need to define the gdbc URL. To do that, let's string dot data source dot URL. Okay, then you're going to write gdbc, then column, then Postgres, did I wrote it correctly? PostgreSQL. Then we'll continue with our host. It's localhost in our case. The port is 5432. Now you need to define the database name, which was here. It was DemoDB. After that, now we need to define the username and the password. To do that, we need to do Spring, and you can count on the auto-generated suggestion from IntelliJ, which is a great username. The username we said it's demo1. I believe it's demo1. Yes, let's check it again here. Okay, it's demo1. The password is 1971. Let's define the password. Spring data source passwords 1971. And the most important thing that we need to define the driver that we need to use. It's a Spring. To do that, Spring data source driver class name. Now our Postgres driver will be postgresql driver. Okay, and this one, in order to use this driver here, you need to make sure that you have imported the right dependency for that driver, and we did that, as I remember. Okay, I think yes, here it's the Postgres SQL. Okay, now let's just run this just to make sure that we have all the dependencies downloaded successfully, and we have no errors, so we are good. So now our application is connected to the Postgres, but there is no way to find that because we didn't have any tables generated or whatever. So let's start by creating an entity, Java class. Let's call it users. Okay, now for this one, it's gonna be entity. So now it's saying an error. It's not an error because we didn't continue. It's saying persistent entity user should have primary key. So we need to add an attribute. Okay, here we go, it's auto-generated. Now since we since we got Lombok in our dependencies, there is no need for the getter and the setter. We can get rid of these for cleaner code and use the the annotation data from Lombok, which will be responsible for generating the getter and setter. Now for this users, it's a it's an entity at the end. So we are going to define the fields of that table. As you can see, we have created the ID, which is the primary key, and we identify that this ID is a primary key by using the annotation ID from Jakarta, as you can see above. Now, what else we need? We need to define another column. It's a private string name, and we need also another column. Let's call it private string email, and also let's get another string occupation. I I okay. I think I forgot an extra C. Sorry, this is private. And what else we need? Let's keep it simple as this. Okay, let's keep it simple like this. No need for extra. At the end, we are just testing how to integrate with Postgres. Let's rerun the application. Okay, now since we have created a user, an entity, let's say, or a model, and we use the annotation entity, this one is enough to go and tell Postgres using GPA to create this table. So let's now when we run the application, um, we should see this user's table. We should use it in we should see it in our table. So let's check the Postgres database. Let's do a refresh, and it wasn't created. So we forgot something. Related to the GPA, which called spring. Oh, sorry. Spring dot GPA dot hibernate dot DDL slash auto. Here, this annotation is to tell Spring Boot application and to tell GPA how to deal with the entities that you have in your application when the application is starting or on restart. Like either to not do anything, disable DDL handling, or create the schema and destroy previous data, and this is not good. Create and drop, which also not practical way. So we are going to use update. I think it's the safest one. So let's rerun and see. Okay, see, we are getting an error here. So it's picking the update, saying error executing DDL. Okay, near user. Okay. I think we must get rid of this and run it again. And here we go. If we check the database now, okay, our table is created. So let's read data in console by hitting this. It will create a select statement for us. And as you can see, the table was auto created by the GPA and it's empty. Okay. Now let's start by creating some APIs that will be responsible for adding a user into this table and fetching a user by ID. So to do that, we need to create our controller. Let's call it demo controller, and of course this is a REST controller, and let's add the request mapping. Okay, all our APIs will start with v1, and um, before creating the APIs, actually there is one important interface that we need to create to communicate with the database, which is called the repository. Now, as you can see here, I'm not following any packaging best practices. So this is at the end for teaching purposes, specifically for Postgres. So usually the packages should be like this. For example, here I'm gonna create a repository for communicating with the database. So let's create a new package called repositories. In this package, I'm gonna create a Java class. It's an interface actually. Let's call it user repository. User repository is gonna it's gonna extend GPA repository. The GPA repository is expecting two parameter, which is it's the model itself that we have created, which is the users, and also it's expecting the ID, the primary key data type, and in our case it's long. Okay, so by using this GPA repository, of course it will inherit all the functionality that exists in this GPA repository, like it will provide you with 90% of all the functions that you need to do on that table, like find all, delete, save, etc. And also this GPA repository is extending another predefined classes, like here list, pagination and sorting, and this is for CRUD repository. This is for finding all by ID, etc. Okay, now in our controller, let's build the first API that we need to use to create a customer. So let's start by, let's see, this is a post mapping. Let's call it user, and this will be public. It's gonna retain response entity. Let's call that function add user. Okay, add user. This will be a post mapping, so we need to send a request body to it. Sorry, request body. The request body will be of type users. It's an object at the end. It's called user. Now, in order to insert a user into our database, whenever we receive that request, we need to communicate with the interface that we did. Now, since this is extending GPA repository, this must be annotated by repository. Here in the demo controller, all we need to do is auto-wiring that interface. It's called user repository. Now, all we need to do is using that user repository dot, and you can look into all these functions provided by the GPA repository. And there is a function called add, I believe. It's called save. It's a save, yes. So that function is expecting a user object, because in the user interface we have defined that this user repository is dealing with this model. This model is the class and the entity that we have met. So we simply will pass the user object that we got in the request. Now, as you can see here, we didn't initiate like in the normal way of Java, like we didn't say like this user equal new user and start initiating the field. There is no need for that since we are using the request body annotation, and since we have already defined our model, when the request will be having these fields here. The request that we will get in the request will have the name, the email, the occupation. So the controller will understand how to inject this field into the user object and initiate that object. Now, okay, after getting user deposited save, it will create the user. What we need to do, we need to return a response for the channel. Let's say response entity. That's here. We need to return a new object of response entity. In the response entity, we are going to send two fields. One is the user that has been created. Two, the HTTP status code, will be HTTP status dot. Okay. Okay. Now let's rerun this and test the API. I need to open my Postman. Now in order to call that API, we need to use our localhost, and our application is running on port 8080, and the request mapping is consists of v1, so we need to send the v1 and the name of the endpoint here, which is user. Now this is a post. In the body we need to send these fields, like it's gonna be the name, let's say it's Murad, the email, also we need to send the occupation. Okay, now let's hit enter. So it seems when we run the application, we get into an issue when inserting the user. As if you can see now, let's run the application again. Now if we run the application, it's getting inserted, okay, but these values are not being injected into the fields in the model. So it seems there is an issue. It's a common issue actually when using Lombok with GPA. So to get rid of this, let's just create the getter and setter in the normal way, which is in generate getter and setter. We are going to use only all the fields except the ID, because the ID is auto-generated value. Okay, so let's run it again. Now let's start. First of all, let's just delete all users. We have nothing, but let's make sure. Now let's run the API again, and as you can see, we got success. We got the details of the users we have inserted. Now if we go to the database, do a select, we will find that our API is inserting successfully into the Postgres database. Now let's add a couple of users. Say Jack. He's an data engineer. Let's add Emily. Also, it's a data engineer. Okay, now we will have 3 users in our database with auto-generated ID. from GPA. Now let's go back to our controller and create another API to utilize the function where we can retrieve all users from the database. It's gonna be a get service. Call it also user. Okay, this one will we will get a user by ID public. We will gonna return a response entity get user by ID, and here we are going to pass a query parameter. Actually here it's gonna be a long ID, and now we will use the user repository that we have injected to find by ID, pass that ID. Sorry, this is will be a user. Okay, now return a new response entity. We are going to return the user that we have retrieved from the GPA repository, and we are going to use the code as okay. Oh, sorry. It's okay in capital. Now let's run this again. Now where is the postman? Okay, it's gonna change this to get. There is query parameters, it's called ID, and you are gonna pass one of the IDs from the database, this one, and send. And as you can see, we received a JSON response with that user details. Now, how we get this response is because we use the response entity as a return type. Also, the user repository here will get the details and map it into a user object since it's using this. So it will retrieve based on the ID. It will map all the details from the database into this user object. And this is all for integrating a Spring Boot application with Postgres application. Of course, this is an overview. It's a demo for learning the concept. Here, this GPA, the most important concept is that this GPA repository will provide you with a lot of functions that you can utilize. So here, if you go and write user repository dot, it will give you everything, including the delete. If you want to delete a user entity, you can delete by ID, delete by the object itself. You can also check if it exists. To find all, this will return you a list of users. Flush and save all, etc, etc, etc. So this is all. I will leave the URL for this repository into my GitHub, so you can check it to check the repositories. Also, I will leave the Docker image URL and the command that you need to use to get that Postgres running in your local Docker. So yes, hope you like this one. Okay, and let's see you in the next lecture. Thank you so much.